Hello people, welcome back to my channel. So today in this video, what we'll be seeing is when we do clustering and when we do different types of algorithms or when we implement certain machine learning algorithms. Usually in some of the algorithms, what happens like in k-means or in knn, we have to decide the value, that is the special value of k, which is nothing but the hyperparameter. So it often becomes very difficult to estimate what should be the optimal value of k and how we should set it, because in the literature there are different techniques or different methodologies by which you can decide upon this. But today what I'll be showing you is like a small way or a small automation basically, which you can run on any data set for deciding the optimal number of k in k-means algorithm. Uh, Now in KNN also you decide k, but there the role of k is the neighbors, that is the number of neighbors that you want to have. But in k-means it is nothing but the number of clusters that you wish to desire. So from a range of different k values, like say initially we don't have a estimate. So what we do is we just take some value of k in the range of like 10 or 15, and from that we usually decide how many number of k's, that is the optimal value of k we should have for our clustering. So means our data points are well optimally classified in that, or clustered in that. So for that purpose, I'll be demonstrating some piece of code. So first of all, it is very simple. uh, So I'm importing the math library, and for visualization, I have the matplotlib, and I'm using the numpy. Then there is a C1 library. Then from sklearn library, I'm using the k-means package, and there are some other warnings and other imports which you already know because we have seen in the previous videos. So these are the small things that you would need to have, else it would not render on your notebook. And then there is a matplotlib inline, so for displaying all of the graphs or diagrams, everything onto the display or onto the screen, you have to write this line. And there is a sns dot set color codes that will set the color codes by default. And then I'm basically setting a context. So from sns I have a sns set underscore context, uh, whose value I'm giving it as poster. So it will generate a diagram which looks like a poster. I mean, like it will have some bold borders at its surrounding or on the boundary. And then if there are any warnings which is there inside this, or because of any lower versions of Python or from any other libraries, uh, due to that I'm basically suppressing that. So for that I have the warnings dot filter warnings, and I'm just doing a ignore. And from RC params, uh, that is from matplotlib itself, uh, all the figures that I will be generating would be of size 10 comma 5. So that is just small things or the boilerplate things that you would need for this. So here for this demonstration purpose, I will not be having any data set as in, but it will be just random. So as I said random, so I'm taking np.random, and in that I have a method that is seed. So seed basically will generate a set of initial set of k values. So here what I will have is I have 8 number of different k's, that is the k values, and from that I will be selecting the optimal ones. So every time you run this particular line, it will save onto its memory, and it will generate the set of seeds as desired. So that is what this np.random is. And then here what I have is I have three different lines A, B, C, and inside this I am using a np dot random dot multivariate normal. So what this basically does is, so if I go here, so this is the definition of this particular method from NumPy. So it draws some random samples from a multivariate normal distribution. So here what we are assuming is like all the data points that will be generating is a normally distributed point. So in the real life or in the real data set, it's not always mandatory like the data points or the samples drawn will always follow a normal distribution. So for that you have to do certain types of test, significance test, hypothesis testing and all. So I'm not doing that, but this is just from scratch how would you generate some set of points for clustering. So that is the basic ideology for this discussion. So uh, you can use the multivariate normal method from NumPy, and it takes parameters like mean, then covariance matrix, and the size. So these are the three things that I would need, and rest other things are optional. So for that purpose, I will be having an array. So this is nothing but the mean. It is a 1D array of length n. So mean of the n dimensional distribution. So 10 comma 0. So this one particular array or a list, you can consider it as a mean. And this part is your covariance matrix. So it is like 3 cross 1 and 1 cross 4. So the columns here should be equal to the rows here. So it works in that way, and the size is 100. And similarly I have three different uh, variables. So by this what I am intending to do is I want to have a cluster which is of some data points, and it should be three in numbers. So there will be three distinct clusters. So that is my motive of this. And the total size will be of 300. So 300 and two columns. So that is my idea of making this. So, and then what I do is I do np.concatenate, and inside this I'll concatenate all the three different clusters, and I want to put into a data frame, and I'll show you how this basically looks like. So, so see, so this is my, actually this is not a data frame. This is from NumPy arrays. So you have all the 300 points. So this is 100, 300, and two columns. So it is in that way. Okay. So if I write the shape here, so you can see 300 and 2, that is the dimension of this. And if I write the size, it should be 600. Good to go. So now since we have generated this data points randomly, now we would like to visualize this. So for visualizing, I am making use of a scatter plot. So from scatter plot, I have X and Y. So this will be the first column, that is nothing but this one, the first one. I mean the entire column down there. And this is the other one, this one. And this is a parameter that represents the color that you want to give to your clusters. So here I am uniformly giving colors as green, so that's why C is equal to green. If you wish to give any other colors, you can put any alphabet as you wish. And now if I do a plt.show, you can see there are three distinct clusters which you have generated without the help of a dataset. Okay, so this is from scratch how we can generate some random set of points and for clustering. So for analysis purpose, we can use this kind of codes. Now, what I do is, since I assume like you know about the k-means algorithm, how it basically works. So initially we get some points that we already did. Now we have the clusters in front of us. Now we want to get some centroids. So centroids are usually taken as random. So from centroids, we calculate the distance to each points within that particular clusters, and then we do that activity for all the points. So for that, what I'm doing is I'm declaring a list here. So that is the distance of points from the cluster center, that is from the centroid central value, and the k that is that I'm having here, that is in the range of 1 to 10. So it will run from 1 to 9. So you will have 9 different values of k, that is k1, k2, k3, k4, k5 up till k9. So k will have a value of 9. So what we are doing is, from a range of k values, that is of 9 values, what should be the optimal value of k for our clusters, that is for this particular setting. So I am running a for loop for number of clusters in k. uh, I have a model, that is k model, and I'm calling this k means from the sklearn, that is number of clusters. N clusters is number of clusters. So it will go inside this, and it will basically calculate the model dot fit, and then I'm basically appending to this list what I already declared here, and that is k underscore model dot inertia. So this is the point, or this is a built-in method which is there in k-means from the sklearn library, which calculates the centroid value, and it will put onto this. And once I run this, and if I look at the list, you can basically see the distance of all the points from the cluster center. Now what I can do is, I can take the k values, that is from 1 to 9, that is on the x-axis I will have 1 2 3 4 5 6 7 8 9, and on the y-axis I will have the distance of points from the cluster center. So here you can see the higher ranges, some 7,403, then 2,000, 2,000, 1,000, and it goes up till 934. So it will automatically plot that. So you can see, so this value higher corresponds to 7,000 something, and the lower value, so it has basically a unit difference of, on the y-axis of 2,000. So even numbers 2000, it's 20,000, 40,000, and 60,000. And here on the x-axis you have the k. So here it is 0 1 2, then 3 4 5 6 7 8, and 9 also there here. So it is like on the x-axis 2 units, and on the y-axis it is 20,000. So now this is nothing but your elbow method, which we usually use in k-means to determine the optimal number of clusters in k. Uh, and so how do we determine that? By graphically we can see like where there is a significant bend. So that is nothing but on this portion we can see a significant bend. So then we decide like we should take the k value as 3. But if some other person by mistakenly said like the k value should be 2, right? So this here there is also significant bend, but it's not that significant as compared to this, because here there is a sharp bend and after that it goes flat, that is to 0. So now the question is like, to which to consider which k value, whether k is equal to 3 or k is equal to 2. So in order to avoid that confusion, we have a technique, that is by joining the maximum and the minimum point and then inverting that. So that comes from calculating a point from a straight line. So that is from the mathematics that we estimate. So before that, let me plot what I have currently spoken. So what I want is, so this was our plot originally. So what I want is, I want a straight line, or I can call it as a line segment, okay, which starts from k is equal to 0 to k is equal to 8, because then we will have 9 different values, that is 0 to 8 will have 9 different values, so that represents our k. So the plot here will have k0 to k8, so those 2 points are fixed. Then the distance of points from cluster center 0 to the distance of points from cluster centers 8. So this we obtain basically from the list that we have here. So all these values will be plotted, and this is a parameter which will basically draw that line. So let me just run this and show you. So the resultant of this will produce something like this. So this is k is equal to 0 to k is equal to 8. So it will span all the values, that is ideally speaking it should take all the 9 values. So this is how it looks, and if I just remove this minus sign, we can see only 2 points. So that is nothing but k0 and k8, k of 8. So we'll just go here and we want this plot on top of this plot. So we want both to be combined. So for that we have like this. So now you can estimate which is the maximum distance. So if I ask you, just draw a straight line to this perpendicular. So you can draw from 1, we can draw a line like this. From 2, we can draw a line like this. And 3, we can draw a line like this. 4, 5, 6, 7, 8. And then if I ask you which is the maximum of that, so maximum should be this one. So from this point to this straight line, that distance. So for that, in mathematics we have something like distance of a point from a straight line. So how to find the perpendicular distance of a point from a straight line is given by this equation. So if you have a system of equations like ax plus by plus some c constant is equal to 0, then this is the formula for that. You take the absolute value of ax1 plus by1 plus c and you divide it by square root of a square plus b square. This website will give you a detailed overview of the proof and everything, but we don't require all of these things. Just for our plotting purpose, I've just shown you that. So this mathematics which you see here, that I translated into code, and for that I'm putting a function. So now henceforth we'll be doing this and as an automation. So every time when you get new data set, you can directly put onto this. You can set the values for a b c x1 y1, and then you can produce this. So the resultant that you get out of this would be the value which will have the maximal distance, or all the distances it will calculate, that is a perpendicular distance. So that is nothing but here. Okay, so it takes 5 parameters x1 y1 a b c from this particular equation. So by looking at this equation, I am making this function calculate distance, and now we want to set the values. So a value is nothing but the distance of points from cluster center 0, and that I'm subtracting from cluster center 8. So that is nothing but common difference from the minimal point to the maximal point. K8 minus K0, So that is on the x-axis, and this is on from the y-axis. And to C1 I have a multiplication factor, so that is nothing but the a into x1 and b into y1. So that I'm doing this here, and to a single value what I'm doing is I'm just subtracting c1 minus c2. And if I just run this, and now here what I want to do is I want to maintain this particular result also into a list. So distance of points from line, I'm making it as a list, and inside that list I'm basically uh, putting that. So for k in the range of 9, that is 0 to 8, it will run till 8, it will not go to 9. So distance of points from line to this list I'm appending this particular thing. Now what is this thing is nothing but I'm doing a recursive function call here. So every time it will calculate the distance, it will go to this particular function, it will return the d. So for each k, so here I have a range, that is it will take the first value 0, it will pass to this equation distance of points from the cluster center of that is of 0, then it will take all the values from 0 to 8, it will calculate this every time. So you can reuse this code, and if I just run this, and now if I plot this k value and distance of points from line, uh, this particular plot was different. So here this is distance of points from cluster center, and this is distance of points from the line. Okay, so if I run this, I get an inverted graph. Obviously this graph, when you invert it, you'll get in this way. So from here you can estimate the maximal distance. So by graphically you can see the maximal distance occurs at value of k is equal to 3. If you want to just print it, you can print by using the index. So we access the distance of points from this line. So you can see here from this two graphs, what difference you can make out is that the x-axis remains the same, but on the y-axis you get 0 to 4, 6. Okay, so that is due to this particular activity. This is just for plotting or for calculating the distance, and from this we get the maximal distance. So we are interested in estimating the k value, so for that we get the k value of 3. So from the diagram also we can make this out, but why did I come up with this topic is like usually we do the elbow method, or we say the elbow method is used for determining the optimal number of clusters in k-means, but you should not stop there, because sometimes the elbow doesn't looks that significant, or the elbow doesn't looks like a elbow method. Okay, so there it becomes very difficult if you do it intuitively. So for a better way, you have to join the minimum and maximum point, and then you have to calculate the intermediate distance, and from that, which is the maximum, that will be the optimal value of k. So that was the entire takeaway of this discussion. So well, I hope you enjoyed this video, and if you found this helpful and informative and educative, please do like, share, comment, and thank you very much for watching this video.